Hey everyone, welcome to another lecture in the DSA series by the ML Hub. So in this lecture, we will be solving some practice problems and PYQs. So let's get started. Alright, so the first point I need to discuss over here is how to implement a stack using two queues. So you might have seen like various problems framed on this concept that two queues are given to you and you need to implement a stack. Okay, so what exactly it means? Let me explain. So you have two queues. Let's call them Q1 and Q2. So if a queue is given to you, the two operations associated with the queue will also be given, which is NQ1, DQ1, NQ2 and DQ2. Okay, NQ and DQ are the insertion and deletion operation in the queue, and the suffix 1 is denoting that we are having an NQ operation in Q1, and with 2 we are denoting it that we are making this operation in the second queue. Okay, so this is like two queues are already given to you. The idea is to use these NQ and DQ methods in such a way that you define two functions, first push and second pop, and it should be treated as like a stack. Okay, so there are two methods to like implement a stack using two queues. The first one is a push costly method, the second one is a pop costly method, and both the methods are same, like there is no much difference, but the way in which you are trying to implement the push and pop. So we will be discussing the pop costly method. All right. So how exactly we can do this? Let me explain. So the first point, okay, so we are making push as a very cheaper operation compared to the pop. Let's use this Q1 to push. Okay. So any new element that you want to add to this stack would get added to Q1. Okay, so the idea is to each push should add the element to Q1, right? So whenever a new element you need to add to this stack, just go and edit in Q1. That's it. So that's all you need to do for implementing the push operation for a stack. Okay, and for a stack we need to have two methods, like the first is push and second is pop. So the idea is to implement this push and pop using these four methods: NQ1, NQ2, DQ1 and DQ2. That's it. Right, and like there are various problems just like framed even in GATE as well on this concept. So this is the push part is handled. So every push just add an element to Q1. That's it. So for instance, you need to perform this operation: push 1, then push 2. Okay, so what it will do, it will go and simply add 1 at the top of at the tail, and then 2, then 3. Let's assume we have added 3 as well. So till now I haven't like popped any element from the imaginary stack using these two queues. I have just inserted these three, like I have just executed these three commands, or I have just pushed 3 elements in the stack. Okay, so let's call it operation number 1. Cool. So next step, so pushes are handled. So every push, like if it's a series of push, just go and add at the end of the Q1. Okay, so now this is the direction of the queue. This is the direction of the queue. So the last element that got added to the queue was 3, correct? So now what if I need to pop an element? What if it was a stack? What if it was a stack? If it was a stack, it will be like this: 1, 2, 3, and the element that I need to pop would be the last one that I've added in the queue. That's when like it will be a stack, then only it will be a stack, right? So I need to design or define the pop function in such a way that whatever element that I am adding at the end of the queue should be the one to get popped out. That's it. So if it was a stack, element 3 should be popped. Pop should return 3. In this case, there is no direct way to return the last element that got added in the queue. Why? Because it is of type FIFO. It is a queue. It is a queue. So the operation that we have, which is DQ operation, DQ1, would eliminate this one and not 3. Okay. So in order to make a pop operation, what can I do? Each pop operation should copy or should move. Each pop should move. What I need to move? I need to get rid of all the elements which are standing in this queue before 3. I need to move all the elements which are standing in this queue before 3. And I'm talking about this dotted section. Whatever element which is present before 3 should get removed from the queue in order to remove 3. Correct? Because it's first in, first out. If 1 was added, then 2, then 3, then 1 will be the element which will be removed on the first DQ operation. But I need 3. So to get 3, I need to get rid of all the elements which are present before 3. So what I can do? Each pop should move all elements from Q1 to Q2 except the last one. Except the last one. And what is the last one in this case? In this case, it's 3. So what I will do is the second operation on each pop, I will start from this one. I will start from the head of the list, head of the Q1 which is, and will keep on removing elements and adding it to Q2. Will move the elements from Q1 to Q2 except the last one, except 3. Okay, so in this case, if I need to perform, what if the second operation was a pop operation? What if the second operation was pop? In this case, I need to follow step number 2, which is the pop should return 3, which was the last element got added. Why? Because we are trying to implement a stack. So I will move this one to Q2. So this will be removed and 1 will be added to Q2. Q2 was empty initially. Then this 2 will be removed and it will get added to Q2. And then we are moving all the elements except the last one. Except the last one. Why? Because this is the element which should be returned on the pop operation. Right? So this is the last. So this will simply pop out. Return this. This DQ, the third DQ of Q1 will return me the desired element that I need for the pop operation. Popped out. Right? So after second step, what is the value of Q1? In this case, let me write it here only. After second step, the Q1 would be empty and Q2 will be 1 and 2. Q2 will be 1 and 2. Okay, so let me add the values of Q1 and Q2 for first step as well. Yeah, after first operation, the value of Q1 will be 1, 2, 3 and Q2 will be empty. Why? Because there is no pop in this one. Okay. Then the next step is swap Q1 and Q2. No, first we have to return this one. Each pop and then return the last element of Q1. Return the last element of Q1. In this case, it will be 3. Okay. So at this point, Q1 is empty, and all the elements which were in front of the last one, which is 3 in this case, 1 and 2 will be moved to Q2. In this order only, because initially Q1, Q2 would be empty. So both head and tail would point to 0 index, and then after 2NQ operation, after 2NQ, the head will remain at this, and this will be the tail. Right? And the last step, swap Q1 and Q2. And what is the meaning of this swap? By swapping means we will be just calling this Q2 as new Q1. This Q2 as new Q1. It will be Q1 and this will be Q2. We just swap the pointers. That's it. Okay. So why it is required to follow this sequence of operations? Because the next push you want to make would be the one after this 2, which is already present in previously called Q2 but now is Q1. Right? So what if I need to push 4 and 5? So this 4 and 5 will be added to this. This is now Q1, not Q2 anymore. So 4 will be added here and 5 will add here. So after this operation, the value of Q1 will be 1, 2, 4 and 5. 1, 2, 4. And 5, and Q2 will be empty. Q2 will always be empty. Q2 will always be empty. Q2 is just an additional queue that is required in such a way that pop operation can be performed smoothly. Not smoothly exactly the way in which we want, which is the last element got added to the queue should be the one to be removed and not in the regular scenario, which is first in, first out. Alright. So this is a pop costlier method. This is a pop heavy method. This is a pop heavy method. Why? Because push will always take big O of 1 time complexity. Push will always take big O of 1, a constant time complexity. Why? Because push is simply just adding at the end of Q1. But in pop, it is removing all the elements from first queue. So if there are say n elements in the queue, n minus 1 elements will be removed and got added in Q2. So it will take big O of n time complexity. Big O of n time complexity. That's why it's called pop heavy. Push is a lighter operation, constant time operation, but pop would take big O of n time complexity. Okay. So in this way, you can implement a stack using 2 queues. Alright, and like you can correspondingly argue that I can also have it a push heavy method. In that case, every push should be in such a way that the pop should take that constant time complexity. So it is like very much possible. It's not that difficult. Alright, so yeah, that's it. Now there is one more way in which like I won't be discussing it over here. You can take it as homework. I want you to try it on your own. And what exactly it is? You want to, I need to implement a queue, but using 2 stacks. I need to implement a queue using 2 stacks. So in previous one, I have implemented a stack using 2 queues. Now I want to implement a queue using 2 stacks. So think over it, how exactly we can do it, and you can try it out and like as an homework. All right. Yeah. So next question. So this question was asked in GATE CS 2004, and the question says a program attempts to generate as many permutations as possible for the string ABCD. A string is given to us ABCD, and the program is trying to generate total permutations possible for the string by pushing the character. So there is a way in which like it is trying to like generate the permutation, and it is by pushing the character A, B, C and D in the same order. So the order is in the same order into a stack. So a stack, so it's a problem on stack. Okay, and the order is first A, B, C and D. So this is the order in which it is the string gets traversed. Okay, but it may pop off the top character at any time. The constraint is it can pop the top character at any instance. So which one of the following string cannot be generated using this program? Okay, so the scenario is you have a stack and you have a string, and this string is traversed from A, then B, then C, then D, and in each iteration it is pushing that corresponding character to a stack. Okay, and the one more condition is like it can remove the topmost element which is present in the stack at any time. So it may pop off top character at any time. So at any instance, the top element from the stack can be removed. Okay, so which one of the following cannot be generated using this program? And what is the generation, what is the string that will be generated, which is the order in which you are making the pop, right? So let's see. So initially I have a stack and it will be empty, obviously. Initially I have a stack and it's empty. Okay. So the first character that I will see in the string would be A. Why? Because it is written that we are reading from left to right. So A will be the first character, and whenever a character is read, it will be pushed straight away to the stack. So it can the first operation would be always push. First operation will be push A. I'm not writing S comma I. You can think of explicitly that I'm talking about this stack only, S. So push A would be always the first command that the program will give, no matter any other possibility is not possible apart from pushing the first element. Okay. Now second case. What after this push? After this push, this pointer will be on B. This pointer will be on B. So now two things can happen. Either it can go and push A, not A, it can go and push B, first possibility, or it can pop the top of the stack. Why? Because it is written as, but it may pop off the top character at any time. So it can pop before pushing B in the stack. It is very much possible, right? So in either of the scenarios, let me move it slightly on the right. Yeah. So if it's the element, if this push operation got performed, so what will be the value of stack? I'm writing it down in a horizontal manner. So the value of stack will be A, comma B. That's it, right? And this is the top. This is the direction of the stack. Correct? But what if the pop was performed before you add that element B? In that case, what will it return? It will return A. A was at the top. This will be removed and returned. And then the stack will only have B. Right? So we need to maintain two things: the current value, the current order in which the characters are present in the stack, and output string. So initially it will be empty if the B got pushed, but in this case output would be A. Output would be A. Is that clear? Why? Because we have performed pop before pushing B to the stack. So pop will add A to the output and it will get removed from the stack, and then we pushed B. Correct? So this will be the way in which you can generate all possible combinations of this output by considering all possible scenarios like this. Okay, but in exam, it is not a very good way to sit down and try to figure out all possible combinations. The better way would be to check options, whether if we understand, if we understood what exactly the process is. It's the sequential push, and at any instant you can pop the element. So you can easily figure it out by seeing the option that whether the specific output is possible or not. Let's see it. Starting with option A. So the first option is A, B, C, D. First option is A, B, C, D. I'm removing it. First option is it possible A, B, C, D? This is the value of this output string. So the order in which I am pushing the elements are A, then B, then C, then D. So if I take the stack in such a way that I push A and then pop it out. So the output will be A, then I push B and I pop it out. The output will be A, B, then I push C, pop it out. The output will be A, B, C, and then I push D, pop it out. So A, B, C, D is very much possible. And what will be the pattern? The pattern will be I push A, remove it, push B, remove it, push C, remove it, and push D, remove it. So option A is possible. We need to find the string that can't be generated using this program. Okay, so option A possible. Let's see the next one, D, A, C, B. D, A, C, and B. So the order in which, like, this is exactly the order I need. This is the order that I want to make by the pop operations. So the first element is D. The first element is D. The only way in which the first character of the output string will be D after I perform all push operations. Otherwise, you can't pop it out. Why? Because we are like traversing these characters sequentially. The first is A, then B, then C, then D, and it's a stack. So the last one that you have added would be the first to be popped out, right? So if I want the first character to be D, all the push operations should get completed. Otherwise, it's not possible. So for this, what will be the stack? It will be A, B, C, and D. And now if I go and perform the pop operation, the output string would be starting with D. Then I can, like, after I have pushed all the elements, there is no other way. There is no other operation left apart from popping the elements out. So D is possible. Then the next would be C only, right? The next would be C. After you pop D, the next would be C. A is not possible. Okay, so let's see only. The option is D, C, B, A. We are referring to option B. So after D, it will always be C, which is correct. We can verify it. Then it will be B. So the B will be popped out, and then finally A. So D, C, B, A is also achievable. We can also get this. So B option can be generated by the program. Now let's see the third one. C, B, A, D. The third one is C, B, A, D. Again, the only way I can get the first character as C will be after I push C in the stack and then immediately performing pop before I push D. Okay, so it will be A first, then B, then C. And now before pushing D, I have just pushed C. Before pushing D, I pop it out. I pop C out. So the output will be starting with C. Okay, now I have two options. Now. Either I can go with pop. If I go with pop, element B will be the next character. If I go with push, in that case, I will add D on top of B, and whenever a pop is applied, it will remove D, not B. But what I want B. So I will hold on with my last push operation and I will remove B. So B will be the last. Now again I have two options. Either I can push D or I can pop A. So the next I want A, so I will pop it out. So it will be A. Then I will perform push D and then pop it out. So CBAD is also possible. How? Push A, push B, push C, remove pop the first element, then pop the second, pop the third, and finally perform the last push, which is D, and then pop it. So this is also possible. Now let's see the last one, CABD. The last option, D, C, A, B, D. So if I want the first character as C, I need to have it A and B pushed in the stack, right? Then I will push C, and before pushing D, I will pop C. The output will be starting with C, okay? Then I want A. So I want to ask you, is it possible? This is the stack. A, then B. The top element is pointing, the top pointer is pointing to B. Is it possible to get A? Is it possible to get A? Is it possible to remove the element which is not present in on the top of the stack? The answer is no. So this is just after C. A is not possible. So A is not possible. So after C, I can either have B, or after C, I can have D. Both are possible. You pop C, you pop B. The pattern will be C, then B. You pop C, you add D, and then pop D. So D is also possible, but CA is not possible. CA is not possible, right? So by this, the answer would be D, because it is asked that which string can't be generated using this program. All right. Okay, so let's have one more problem. It was asked in CS 94. The problem says, which of the following permutation can be obtained in the output in the same order using the stack, assuming that the input is in sequence this. Again, it is the similar problem that we discussed, so you can take it as homework. It is the same problem. Given a sequence of permutation, given a sequence in which I need to perform the push operation, which output, in this case, it's asking assuming can be obtained. It is asking can be obtained. So 3 would be incorrect and only 1 will be correct. So you can figure it out. The idea is the same which we discussed in the last one. So now see the next problem. So this problem was asked in CS 2003 and it's a very interesting problem. So just pause the video and try it on your own. Okay, so what the problem says. So let S be a stack of size n. So consider a stack of size n starting with the empty stack, initially empty. Suppose we push the first n natural numbers in sequence. So there is a stack which is initially empty and we are trying to push n natural numbers sequentially, 1, 2, 3 and so on, n. And then perform n pop operation. So there are n pushes and then n pops. Assume that push and pop operation take x seconds each. Each push and each pop. Let me write it down. So each push takes x seconds and each pop also takes x seconds. Right? And there is one more time given, y seconds elapse between the end of one such stack operation and the start of the next operation. So now every consecutive operation there will be a y seconds time elapse. Okay, what it says, it means that there will be a push operation, then there will be a time elapsed, then there will be another push operation. So this push operation will take x seconds. Again, this push will take x, but in between two pushes, or in between any two operations, it's mentioned between the end of one such stack operation and the start of another operation. Okay, either it can be two consecutive pushes, two consecutive pop, or a push or a pop. There is always a y second of time elapsed in between these operations. All right. So for m greater than or equal to 1, so there is another number m. Define the stack life. Define the stack life of m as the time elapsed from the end of push m to the start of pop operation that removes m from S. What it means? It says I need to perform push operation. Okay, so there is this stack life of this m is we need to find it out. Okay, so we need to find first stack life of a arbitrary m. Okay, m is it's not mentioned here, but definitely m would be a number which is less than or equal to n. So for a m which is less than equal to n, we need to define stack life, which says it is the time elapsed from the end of push m. So it is the time elapsed from end of push m. So there will be n pushes, right? So somewhere between 1 to n we chose m, and then just after you pushed that element m, I need to calculate time elapsed from just after pushing m to the start of pop operation that removes m from S. So let's see the sequence of operations that we need to consider for this problem. So the first operation would be like there will be n consecutive push operations. So it will be push 1, right? It will be the first operation. Then there will be some gap, push 2, again some time elapsed, and so on till a time elapsed push m, then that time elapsed, and finally push n. So these will be, so there are n consecutive push operations that we need to perform in that stack. Okay, and each push takes x second, right? Each push takes x second, each pop takes x seconds, and in between two pushes the time will be y seconds. So it will take x, then y, then again x, then again y, and so on. It will again take y, x, then y, and finally y seconds and x seconds, right? So if I ask you what will be the time, how much time will it take in pushing all these n numbers, how much time will it take in pushing all these n numbers, you can like straight away calculate that we need to do n pushes. So n times x plus in between n pushes there will be n minus 1 time lapses. So it will be the time that we take in order to perform the n push operations, but it has not been asked in the problem. All right. Okay, so now we are at here, we have successfully completed n pushes. Then the problem says after you perform n pushes, then we perform n pop operations. After you perform n pushes, we perform n pop operation. So we start with the first pop, and if I have to ask you, if I push n natural numbers starting from 1 in the stack, so what number will be the one that will be popped out? This one, right? The last I pushed, which is n, this will be the one that will be popped out. So first pop will return n, this will return n. Okay, then there will be a interval gap between the next pop, which will return n minus 1, this will return n minus 1, and so on, right? Then a gap. So it somewhere in between there will be a pop operation, somewhere in between there will be a pop operation that will return m. So we are interested in this pop. Okay, and finally the last pop operation will return you 1. Why? Because 1 was the first number that we have pushed in this stack. It will return 1. Correct? So here is the sequence of operation. First n pushes, and then immediately after the last push, which will add n to the stack, there will be a pop, and you have to consider that there will be a gap. Why? Because a gap of y seconds after the last push and the first pop operation. Why? Because in 2 consecutive pushes it's okay. In 2 consecutive pops, if it was pop, then some gap, some wait, so this will take x, this gap will be y, and this will be x. But in between one push and pop, again there will be y seconds of gap, right? It is what mentioned in any 2 stack operations, whether it is 2 pushes, 2 pops, push then pop, or pop then push, it will always take 2x plus y time. If it is a push, then gap, then pop. In this as well, it will take 2x plus y, x for this push, y seconds for this pop, y seconds for this gap, and x again for this pop. So any two consecutive operation will always take 2x plus y seconds. Okay. So this is what is mentioned in the problem. Now let's come to the stack life. So stack life is a function whose definition is given in the problem, which says consider a number m. Stack life will tell me the time elapsed from the end of push m. From the end of push m. From the end of push m. This is the time that push m ends. Just after the push m is ended. So I need to calculate time starting from this, say t0 point, t0, just after push m, to the start of pop operation that removes m. It is not mentioned I need to do for mth pop. It is saying I need to start my stack life just after I pushed m till the number m is removed. Number m is removed. M is removed from S. So in between there would be a pop that is responsible to remove pop. Okay. So just before pop m, just before, let's call it T1, just before the pop operation that is responsible to remove m. Okay. So now let's consider an example. Okay. What if you have only 4 elements, and what if n was 4? What if n was 4 and m was 3? This is for simplifying the stack life that we will be defining, right? So if n was 4, so the order in which you will be pushing elements would be 1, 2, 3 and 4, right? This will be the order in which you will push the elements. I am not talking about time. I am just asking the order in which we are putting the elements and then popping it out. So if, for instance, m is equal to 3, so I need to define the stack life which will start after I push m till m just before m was removed. Okay. So last I pushed was number 4. Okay. And the second last I pushed was number 3, and m is in fact 3. So can I say this? Can I say this for any arbitrary? So for any arbitrary m, see the number of pushes. So how many push operations I need to perform after I push m? If I have to push total n elements, it will be m minus n. It will be n minus m. Yes or no? If in total I need to push n elements and I have already pushed m out of them, okay, the remaining number of elements will be m minus n minus m, right? So I need to perform n minus m more pushes just after I have pushed m. So the stack life of m will be, we need to calculate the time, right? So first we need to calculate the total number of pushes, which is n minus m more pushes are required, and each push takes x seconds. Each push takes x seconds. It's already mentioned. Each push will take x seconds. Right? And now one more thing. See this point. This is push m plus 1. This is push m plus 1. And before every push, there is a time lapse of y seconds. Why? Because we need to wait y seconds to perform the next operation on the stack. So for n minus m pushes, I need to wait for, like, each push will wait for y seconds, right? So this n minus m push operations will take x seconds for individual push plus y seconds of waiting time, that is just before each and every push, starting right away after push m. Okay, is this clear? So this x is responsible. This is basically for the pushes and n minus m. Let me write it out separately, it will be a bit more clearer. So n minus m total pushes plus n minus m of wait time. This is the wait time before each push. Wait time Okay, before each push. Clear? So till now we have successfully calculated the time till this push, the last nth push, and then there will be y seconds. Why? Because the next operation, which is the first pop, will be will occur after y seconds. Why? Because there is the last push, and then we are like starting with popping out the elements. So we again need to wait for y seconds before the first pop operation starts, right? And the next is, so like the total push time is like, we have calculated, and now we are at this point where we can immediately start with the pop operations. Okay, so now let's see the total number of pops that are required to reach the point where the next pop is number m, where the next pop, it is not the mth push, it is the pop that will remove m from the stack. Okay, all right. So now let's come to this example. So what if m was 3? In this case, tell me the number of pops that will occur just before m is equal to 3 will be removed. Only one, right? Only one pop is required. The first pop will remove n, and then just immediately it will be m, which we get. So we need to calculate. It will be always n minus m pops. Can you see it? It will be always n minus m pops before number m will be removed. Why? Because pushing is in this direction 1 to n, and then popping it from n, then n minus 1, then n minus 2 till n minus m, right? And just before n minus m, the immediate next element that will be popped will be mth. And it also makes sense. Why? Because after you push m, you are making n minus m more pushes. Okay, so until these n minus m pushes are removed, then only you can remove m, right? So the number of pop that will be occurring before m is removed will be n minus 1. Why? Because after pushing m, you have further added n minus m elements in that stack, right? So this is what the total number of pops will be before m will be removed. And we need to, the stack life is defined in such a way that time elapsed from end of push m to start of pop operation that will remove m. So I just need to consider the time which is immediately before the pop operation that will remove m. Okay, so the first we have already counted the total number of pops. It will be n minus m. Why? Because after you push m in that stack, there are further n minus m pushes. So you need to remove these n minus m elements before m is removed, right? So this is for individual pop, this, and so on, times x plus there will be time. You need to count these y's as well. Yes or no? This is x, this is x. So x, we are like it's clear, but we also need to calculate the total number of y's that will occur just before the m is removed. Okay, so it is equivalent to calculating x plus y's. Each pop is associated with a time elapsed until the next pop starts. Okay, and we need to we are also considering the last time elapsed. So it is same as n minus m times y. So this is what the stack life will be. Okay, so you can write it as n minus m is common. It's 2 n minus m x plus y plus y. But this is not the answer. The question is asking us to find the average stack life of an element in this stack. So this is stack life. We need to find the average stack life. What will be? It will be summation m starting from 1 to n divided by n. This will be the average stack life. Okay, so let's calculate it. So stack life we already have. So average stack life, we need to just take the summation over like m and divided by n. Why? Because it's average. So 2 times x plus y would be treated as a constant. Why? Because we are taking sum over m. So n minus m, it will be n times summation of 1 from m 1 to n. So it will be n minus m. So m is it is sum of m all natural numbers. It is n plus 1 by 2 minus n plus 1 by 2 plus y times n. Why? Because when this sum will be multiplied by this y, it will be y times n. So this is what y times n is. So we'll just calculate it and get the divided by n. So just calculate it and it will be, and simplify it. I think it will be C. You will get option C, n times x plus y minus x. So this is the average stack life of an element in this stack. Okay, and it will be independent of m. Why? Because like we have already taken average, but stack life SL will depend on m. So this is stack life. This is stack life. Right? So yeah, it was a really good problem. Okay, then move on to the next one. Again, a PYQ asked in CS07, and the question says we have a postfix expression with single digit operands evaluated using a stack. Okay, note that this is an exponential operator. The top 2 elements of the stack after the first asterisk is evaluated. So we have already seen how to evaluate the postfix expression. Okay, a postfix is given and all are single digit operands, right? So it's 8, then 2, 3, exponent, divide, 2, 3, asterisk, plus 5, 1, asterisk, minus, and that's it. So this is the expression given to us, a postfix. Okay, and top 2 elements of the stack after the first asterisk is evaluated. Where is the first asterisk? This is the first asterisk. So after this is evaluated, we need to give the top 2 elements of the stack after this first asterisk is evaluated. Okay, so let's see. So here comes the stack. Starting with, we'll put 8. So we just need to follow the postfix simplification, how to evaluate a postfix expression. Okay, so the first, there will be 8. First there will be 8. We will be pushing it in the stack. Okay, then 2, it's an operand. So whenever an operand occurs, just push it in stack. 2 will be there. Then 3, we'll put 3. Then there is operator. This is an operator. Whenever an operator comes, what will you do? You will do 2 consecutive pops. You will pop 3, you will pop 2. First pop will be second operand. First pop will be second operand. OP2 would be 3. OP1 would be 2. And you will simplify. The simplification will give you 2 to the power 3, which is 8. Push back, right? So there will be 8 in the stack. So till here we have simplified. Then again, next, one more operator. So whenever operator occurs, do 2 pops. 8 and 8 will be popped. The second OP2 will be it's same for both the cases, so it won't change anything. It won't create a difference basically. So value would be 8 by 8, which is 1. You take 1, push. Correct? So at this point, till we have resolved this, the value, the top of the stack is 1, right? So then the next one will be 2. Straight away push it in the stack. Next is 3. Push it in the stack. So let's at the same time try to remove so that it won't create any confusion. We have simplified till 3, right? So the next is asterisk. Okay, so whenever this asterisk comes, so the question says the top two elements of the stack after the first asterisk is evaluated. So we need to resolve this asterisk, and when we are here, then only we need to give the top two elements in the stack. Okay, so when this asterisk arrives, we need to do two pops, pop 3, pop 2. Second operand would be 3, the first pop, and first will be 2, and we will be calculating 2 times 3. So it's 6, push it, there will be 6 on the top. So once this asterisk is evaluated, what are the top two elements in the stack? The first one is 6 and second one is 1. Top two elements, answer A would be the right answer. After asterisk is evaluated, what are the top two elements? 6 and 1. In fact, it is like these are the only two elements present in the stack, right? But like, what if you just miss this evaluated word? What if this evaluated word got like you miss it? In that case, you will provide the top two elements of the stack when you are seeing this asterisk. So those elements will be 3 and 2, which is also an option. But it's incorrect. Correct answer is A. So be careful and do not jump over the answer as soon as you see it in an option. Always re-verify from the problem before finally like you marking the correct one. All right. Okay, so the next one, again PYQ, it's on queue. A queue is implemented using an array. Right? Such that NQ and DQ operations are performed efficiently. Which one of the following statements is correct? N prefers the number of items in the queue. So there are like 4 options given. You need to choose the most appropriate one. Okay, it's a single correct problem. Let's check one by one. Both operations can be performed in big O of 1 time. It's an array, you have to consider it. Both NQ and DQ operation can be performed in constant time if you are using an array. Both NQ as a queue, both NQ and DQ what is the time complexity? Is it like constant for both the scenarios? The answer is yes, it is. Why? Because we have seen it in the class as well. The implementation of queue using an array can be done, NQ and DQ can be done in constant time complexity by taking 2 pointers, head and tail. If you maintain 2 pointers, you can exactly know the position at which you need to add any element in constant time, and at the same time you know the position of the head, so you can remove the element in constant time. So A is the right answer. B option says at most one operation can be performed in, no, both can be done in constant time complexity. C is worst complexity for both operations. No, it's incorrect. This is also incorrect. And finally, worst case complexity for both operations will be log n. Incorrect. Both are constant. Why? Because like adding an element at a specific index in an array and removing is like DQ is just an update in the head pointer, and NQ is add a specific element at tth index and then increase the value of t or increment t by 1. That's it. So A is the right answer. So it was the easy one. Next one, asked in gate 23, consider sequence A of elements. Okay, A0 is 1, A1 is 5, then 7, 8 and 9, and finally 2. The following operations are performed on a stack, and so you have given a stack S and a queue is given and some elements, a sequence A0 to A5, 6 numbers are given to you. And it's mentioned in the problem that both stack and queue are initially empty. So, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's repeated 2 times. Okay. It should be 10 in that case. So 10 operations are given, right? So top element of the stack after executing the above operations is. So we need to give the top element of the stack. Initially both S and Q are empty. Okay, so just maintain and try to follow the steps which are given. This is S and this is Q. Right? First operation, push the elements of A from A0 to A5 in that order into stack. So all, like, push everything in the stack. So stack will be 1, then 5, 7, 8, 9 and 2. Okay, so this is step 1. Like, we have completed the first push operations in the stack. The next is NQ. The elements of A from A0 to A5 in this order in Q. Again, you add this Q. So the order of addition will be the same. That will be 1, 5, 7, 8, 9 and 2. Correct? So we are done with second. Then pop an element from S. Okay? Pop an element from S. Will always pop the last one that was added in the stack. So 2 will be removed. 3 is done. Then DQ an element from Q. And DQ will remove this one. Correct? Why? Because Q, like this is a Q. And 1 was the element which was entered in this Q first. So we always remove from head in Q. We always remove the topmost element in the stack, which was 2. This is also done. Then pop an element again in the stack. The next pop will remove 9. Right? DQ from Q. The next element that will be removed from Q will be this. Correct? Then DQ an element from Q and push it the same. Okay, so in this step we are removing it from Q and putting it in and pushing it in stack. Alright, so 7 will be removed and this 7 will be pushed in stack. So we will add it here, right, on the top. Next step, repeat operation 7 3 times. So we need to perform this operation 3 more times. DQ and add it in the stack. 8 is removed, 8 is added. DQ9, add it in the stack. DQ2, add it in the stack. Add it in the stack. Right? Okay, so we will push the elements from the right hand side while we are removing from the queue from the left hand side. Okay, so this is also done. Now pop an element from S. Okay, we'll pop. This will remove it. And the last one says pop again one more element from S. Okay, we'll remove one more element. So now the top element of S, after executing the above operation. So what is the top element of the stack? This is where the stack is opened. It's 8, right? So it's 8. The answer is 8. Clear? So the problem is easy. Just need to follow them sequentially without making any mistake. The problem just tests the understanding of stack and queue, the order in which you will add the elements or remove it from a stack, and same for queue, right? So this was the recent question. Correct answer is 8. Again, consider the following sequence of operations in an empty stack. Initially the stack is empty. You push 1, 2, then pop. Okay. And then there is a queue. You need to give me the value of S plus Q. Alright. So this is also easy one. So again, consider a stack and a queue. Initially empty, so we are not like putting anything. So these operations are done on stack. The series of operations are done on a stack, right? Push 54. You will add 54 in the stack. So this is done. Then push 52. Done. Then pop. Pop will remove 52 from the top. Then push 55. So this is done. Then push 62. This is also done. Then the next pop is assigned to S. The next pop, which is removed, the 62 will be removed. This will be removed and S will be 62. correct? And same sequence of operation, similar sequence of operation we need to perform for Q, that add 21. Okay, we have added. Then 24. Next is the DQ operation. DQ will remove this 21 from the start. Then NQ 28. Add 28. NQ 32. NQ 32. Fine. Then finally DQ and put it in, assign it to Q. So this will be removed and Q will be 24. So you need to give the value of S plus Q. So it will be S is 62 plus 24. So it will be 86. 86 will be the right answer. Correct? Easy one. You just have to like follow the sequence, the order in which you will add and delete elements from both stack and queue. Alright. So here's the next problem.